The cool thing about this, I haven't even started a presentation, by the way, so it's just a side note. But interestingly enough, this building was put together in 2011. Okay, so this isn't new. This isn't something that happened a couple of months ago. I think 2011. So in that time, the same company has like gone far beyond. They've built like a 47-story building in 19 days. They've done amazing things. But the interesting thing is, if you look at how they did this, they didn't use traditional design methodology. They actually worked they had quite an extensive use of animation-based technology. Animation-based technology allowed them to create what is called a four-dimensional plan, a 4D plan, time-based plan, where they could take a building that was done, disassemble it, put it back together, and track exactly what they wanted to do. So there was a tracking system and everything, and this wasn't used with traditional technology. This isn't Revit, this isn't that. This is 3ds Max. This is your gaming technology at its finest. You know, these very people here are the ultimate strategists. And what has developed the strategy? A childhood of gaming, Mario Brothers, everything that's in. Okay, so what we're here today is we're not here to see buildings being put up and put together. What I'm going to show you is I want to give you a bit of an interesting, unique context into gaming, slightly and kind of a different look at it, a different process of it. So it's getting the max out of Autodesk Stingray. So it's how many game developers are here? People who are familiar with game development. Who've ever put a game together? Slightly, almost. Okay, good. This is the perfect crowd. Thank you. So it's not about actually making a game and developing a game and putting like the mechanics of a game and the story scripting. It's about the essential elements, like where do the models come from? Where do the animation techniques come from? Where does the time-based, the velocity acceleration diagrams come from? And how do you eventually author it, write the program, activate it on key presses and that? You know, it's things that nobody really knows until they know and go, oh, that's how you do it. So I want this to be more fun. It's going to be interactive, so it's highly risky. So anything can go wrong at any time, like anything, so be with me. And at the end, you're welcome to ask any questions. So what I want to start off with is basically, you guys have all seen Autodesk technology. You've seen the buildings go up, you've seen the renders, you've seen the movies that have been made, you've seen a lot of things that are there. So we're in this area at the moment where the very same technology that's used in the manufacturing process is used in the media and entertainment process. We're creating special effects that are better than we've ever seen before, and we're creating manufacturing models that are of such high quality that you can't even tell the difference between what is real and what is not real. So I don't know if you guys were here earlier where we did the automotive show reel. In the beginning, we showed that. It's basically looking at the comparison between your gaming technology and what a game looks like versus what it looks like to design a car in the real world. Okay. So I just want to show you the most exciting video you've ever seen. No, I'm just kidding. So this is a game that was created using Autodesk Gameware a couple of years ago. Okay, for a game called The Crew. Everything that you're looking at is rendered. Everything is animated. Hilux advert? Okay. So I laugh at this as well because what you've seen at the moment is you've seen a demonstration of real-world physics. You've seen how suspensions work, you've seen animation. What you're looking at here, you cannot distinguish between reality and where that line starts to blur. So it's always interesting because whenever you start speaking game development to anyone, they're always like, this is easy. Like, why do you want to do this? Design buildings, design whatever you want. But people don't understand the complexities of the mechanics systems behind it, the programming, the development, the timelines, everything that goes into it is a very, very, very complicated process. So who of you have ever heard of Minecraft? Okay, Minecraft is the second biggest selling video game of all time. Okay, next to Tetris. Okay, there's a bit of a similarity. But what's very interesting is Minecraft is literally a platform to build stuff. In its most neutral thing, it's for children between the ages of 7 and 17 to get together or to figure out what they need to do. They don't even know, but they end up building stuff. The interesting thing about this is this was basically almost solely developed by one person, which is amazing. But it shows the potential for what kind of environments people are craving, people are looking for. So if you look at this, you understand that the very same people that were 7 years old and 17 years old when this came out are now 23, 24, 25. They're graduates, they're engineers, they're architects, and they've grown up in an environment like this where they expect the real world to behave similarly to this. So can you imagine when somebody comes out and they're familiar with a toy or a game that allows them to build what they need, going over to a professional tool and going, wow, the game that I was using actually works better. So what kind of tools do they go back to? Now, in understanding this, I was I come from a process plant technical background, and I read a statistic once upon a time that said that the process plant design industry was a $4 billion industry. I then read that the gaming industry was a $40 billion industry. I was like, whoa, wrong industry, go this way. And okay, this is according to Wikipedia, and this is last year's values. That's here. But if you look at it, mobile gaming at $38 billion, console gaming at $6 billion, and PC gaming at $33 billion. These are massive amounts of money. And the dangers and the construction activities are next to zero. This here can be made on a desktop computer, on a laptop. This is the next generation of construction that we're heading into. Okay, so that being said, Autodesk has got a set of gameware tools that they've released. Okay, not officially, they're kind of still in development, and it's basically off the old BitSquid engine. So a very rare, unheard of version. But they took BitSquid, and they took the best of BitSquid, and they turned it into Stingray. Okay, so they packaged it up with Maya. Anybody in M&E understands what Maya is. You've got 3ds Max, which everybody understands and knows, Mudbox, Remake, and an FBX review service. Now, Remake is interesting because it is the tool that you can use photogrammetry to take photographs of something so you don't have to model it. You take photographs, you get it, you're done, you have a 3D model that you can put into your game environment. Now, what's interesting as well is they've also opened up an ability for you to go in and buy what you need in order to author your own game. You can buy characters, you can buy scenes, you can buy whatever you want. But you can also sell. So if you have 3D models that you've created, if you are not an architect, but you would always love to be an architect, and you have great building design plans, go build a building, put it online, see who buys it. I don't have the image here now, but this here was an interesting one for me. It was a rhino, just a basic little low poly rhino model. It's for $9. It was put up in 4th of August 2015, and it's got like thousands of downloads. So if you say $9 times thousands of downloads for something that was probably put together in a couple of minutes and uploaded online as a joke, sells tremendously well. You start looking and go, whoa, actually, the very 3D models that I can create and I work with, and that becomes something that I can use to actually pay for the software that I use at the moment that I should be paying for. So, there's too many people laughing. So what happens is there's a place called Creative Market, and they're in partnership with Autodesk, and the very 3D models that you create, you upload, sell to them, and see who buys. Okay, so that being said let's play a game. So instead of playing a game, let's make a game together. Let's make the minimum viable option and the most simplistic version of how do we create a game, how do we create a 3D model, how do we add interaction to it? How do we take it to a game authoring environment? How do we program it what we want it to do? How much time do we have left? Kidding. In a small amount of time. And we're going to make it as easy as pushing a button. Okay. Step one. I don't know how to use 3ds Max to create a model. I am very familiar with Inventor. I'm familiar with AutoCAD. I am familiar with 3ds Max. I'm just saying that. But I am more familiar with Fusion 360, a manufacturing tool, something that I can use to make real-world components. So I use Fusion 360 to create a button pressing device. Okay. I begin in the beginning with a basic sketch of an outline of what I want. I extrude it into a shape, give it a nice fancy color. It has to have a fancy color. Go apply a chamfer rule to it, just to make it look good to the eye. That's there. Create another button bottle from the extrusion that I've got over there. Chamfer that, mirror it, add an extra one, and render it up. A couple of minutes, and I've got something that I can use. Now, the interesting thing about this is the way that this works is this allows you to export this as an OBJ or STL or step file or whatever you want, which is the same requirements that you can take and import into 3ds Max. So 3ds Max absorbs a lot of files, so why not take something that you use in a very, who has created a Fusion 360 model? Okay. More of you should be using this. So I've used this and I've created this online, and it's stored there, and I can convert it into a file that can be used and absorbed. Okay. I take it through into 3ds Max, and it loses a bit of quality along the way, but that's fine because we're going to reapply textures to it. And what we do is we have a timeline at the bottom that works. And we've divided the time. I'm going to do this live, so after this. So we have a timeline that goes under 100 frames. Okay. We choose a frame rate of 30 frames per second. So what we know is out of 100 frames, we're working at 3.3 seconds. So I look and I go, okay, this is what I want it to do. I want a left-hand button push, a right-hand button push. I want to be able to toggle this down, and I want to be able to toggle this up. That's it. Pushing buttons. That's easy. So what I do with that is, in working into it, I think to myself, how does a button work? How do you push a button? How do you work with a button? What does it do? It doesn't just go in and out. There's a velocity acceleration that is applied to it. When you push it in, you want it to go subtly in. When it comes out, you want it to feel real. So we animate this and we apply curves to it. So I'm going to show you what we've done with this. And this is the same button that you're looking at. Oh, no. Thank you, guys. I'm joking. Can you come back now? Okay, so in doing this, it allows me to actually create a timeline for certain interactions. So in this case, for some reason, I'm only going up to 30. But I have a timeline of 100, and from 0 to 30, I have the first interaction. So if I play it, the way that it looks when played looks like that. So I'll do it again. So you see how the way that it works, when I click on it, I can see that there's certain interactions. At certain times, it's there, certain times it's there, and there. So actually going to there. Okay, who's animated before? Who knows the concepts of that? Okay, so basically what I've done is I've only given it 3 instructions. I've set it up there, that's where it starts. I've set it up where it ends, which is back at where it starts. And I've given it at the 10th position where I want it to be indented. So that's what creates that different acceleration, that quick press in, but the slow release that's out. If I had to move that to halfway, I would have a very boring motion. But because I play with it, and I've moved it into that, it looks a little bit better. Okay. So when we've applied that and we've worked with that, we can export this over into our games via Game Exporter. Okay, and this allows us to actually go animation clips and set up certain actions. My left-hand side animation. Okay, to 60. I'll call it RHS. And if I click here, I've got a left-hand side interaction. If I click there, I've got a right-hand side interaction based on the time clip that I've taken back. Now, what's interesting about this is these are separate actions. So later on, when I take it into my gaming environment, I can call these at certain times. So if I push the left button, I call this action. If I push the right button, I call the other action. So this allows me to actually work with the mechanics inside here to get it whenever I want to do. So, and this is very, very important. So I can also go create the next one, which is my toggle down between 60 and 80. The reason I know this is because I set this up before, so I'm not just guessing. I'm not that good. Toggle up. Okay, so I've got that action that can be played, that action that can be played, that one that can be played, and that one that can be played at will. So I can call these out. These are the interactions. Now the interesting thing about this is, have you ever wondered when you have a character and then the character runs, jumps, kicks, fights, does everything that you want? It's one character. The character, it's just where you block it off. So when a character is doing something, between this frame and this frame you do this. Between that frame and that frame you do that. Now what's interesting about that is that allows you to mix interactions. So if you ever wanted to push these two buttons at the same time, you can blend them together and have that interaction happening at the same time. It's not like limited to only doing this, and when you click the other one, it goes there. So you can blend interactions. This allows, you know, if you've got a character that's got a sword, while busy running, you can mix the two interactions together, which is interesting. You know, we've got a good gaming mechanic. So that being said, our easy way that we can export this out is we choose the right axis, Z going up. We choose the Z axis going up. So we want to know when it comes into the world where it's pushing and everything that's here. And what's nice is this actually packages the skeleton behind it for us. So the actual mechanic that being used is the center object points of these that actually get exported out, and that gets mapped in later. So if this graphic changes or textures or anything change, it's okay. You know, we've still got a frame, like a skeleton, we've still got a controller that references that. You know, it's interchangeable. Now, if you're working with non-Autodesk, like Unity or Unreal Engine, the moment you export this out, it's gone, go, there. It exists, and any change that has to happen, you have to go back into the original source file, and you have to export it and bring it back in, and set everything up again, because everything's completely new. Now what happens is, because of Stingray, and the way that it works, is there's a live link between it. So if you want to repaint an object, or reanimate it, or just tweak that little bit that you don't like, there's a live sync link, so which saves a tremendous amount of time. And yeah, it's as easy as setting up the times that you want, as specific actions that you can call, and we export this out. So send it to a location.
What would happen if you toggle up again now? Would it jump down?
Oh, it'll just replay it like that. So it just kind of sticks there. So you'll see when we bring this back into our gaming environment. Okay, this is our gaming environment, by the way. So it's very simple. Now, this is a very, very lightweight authoring mechanism. Almost all of the work that happens doesn't happen inside you. This is just where you tell it where to go and where to pull actions behind. So we've programmed the actions behind here that we want. We've already done that and we've exported through. And we kind of set up our scene how we want it. Now, we've got a very basic play. We can select, we can move, we can rotate, we can scale, and we can place on objects. That's pretty much all we can do with our components. So we can't reanimate things or work with them. We can, but it's a very simplistic control. So it's meant to actually do the bare minimum, but allow you to do a tremendous amount of work. So we've got all of the assets that go into it. We've got the materials, we've got previews, we've got the Explorer. But what we really want to look at is the model that we've just imported. Okay, so what happens is when you import it, okay, I don't know if you guys can see, we have a central point. There's no graphic that's inside it. There's no. So we have a skeleton that we work with. That if we look at the animation, the raw animation behind it, we can see there's a. I don't know if you can see there. That moves, and that moves. Okay. So we have a skeleton that's linked up to an animation that we have. Literally, just the two that came with it was the left-hand side press, which is the one side, and the right-hand side press. Okay. So being with that, we need to create a situation now that will call that. So if a certain event happens or a certain action happens, we want one to reach into the processing code and say, click this button, during this activity happens. So we have what is called a trigger. It's easy stuff, guys. It's clicking a button. So we have a trigger that we create from an animation controller. And this is where a lot of the work happens. Okay, it was going to be very bare minimalistic. Okay, so I'm not going to redo it, but I'm going to trust that it still works. So what happens is I want to say that in my default state, when it's my unit is just existing, it's doing nothing. And when it's resting, it goes back to a state of doing nothing. So I create, under the controller aspect, a little process flow almost that says I've got when a certain activity or event happens, I want to go from a default start to a certain animation, which is that first movement that we've got. And then it must go back to rest. So, and then when the other action is called, it goes there and it goes back to rest. If we don't put it back to rest, we can never use the action again. So we always want to take it back to the source that we're working. Okay. So to do that, we just add an event trigger, which places it there, and we draw lines to the situation that we want. Okay, so this allows us to create an activity that we can recall later and attach it to a button. So if the LHS happens, that button moves. If my RHS happens, that button moves. Okay, make sense? Okay, so that being said is we have, this is called an animation controller. Okay. Once the animation controller, once we're happy with that, we close it, we save it, and we go into it, we can go test out our environment. Just go see how it looks. Okay, so nothing's happening at the moment because we haven't given it any kind of instructions. Okay, who of you have ever programmed anything? Okay, so you guys are familiar with the Hello World application. Okay, everybody knows Hello World. Okay, so how do we create a Hello World based application without writing a single line of code? And this is what's quite nice. So I know everything else has scared you guys tremendously, but if we go into the promise of Stingray, is we're not using a coding language in order to create animation procedures. We're using what is called flow. And flow is like the greatest thing that's ever happened to visual scripting. So I want to say that I want to display a message when I press button 1. When I press my unit key 1, I want a message that comes up that says hello world. The traditional printf hello world on key press thing. So to do that, push tab and I say input. Okay, and I can choose that. Or I can right click. And these are all the commands that I can use. So I'm creating a visual entity, a node based, that allows me to connect things up. So I go input, choose input. I can do touch, mouse axis, keyboard button, acceleration, everything there. Every single thing that I could use is already pre-programmed for me. So we don't have to go and make it complicated and find things. If it's not there, I can open up the API and bring it back in. So I go keyboard button. Okay. And I want to do a debug, which is that print to screen. Okay. My Hello World application is as follows. So when my key button 1 is pressed, okay, when number 1 is pressed, okay, I want to print to screen hello world, exclamation mark. Okay, does this make sense? So I have, when keyboard button 1 is pressed, I want to print to screen hello world, and I don't have a color. I can type in a RGB value for it and get a color. But this is as follows. So when it launches, and I push 1, I get hello world. Okay, easy. It's a hello world. Everybody, that's a very easy application. My left-hand side animation trigger. So it's actually easier than that. So what I do is, in this environment here, whatever I select, like if I selected the cube, the floor, or anything, becomes the active unit that I can work with. And I go into level flow, and I know, because I want to program that, I right-click, and I get all of the things that are applicable to that unit. Only the code that is applicable to that. So I'm not guessing what code I'm using. I create the level unit, and every single reference comes from this unit. And I want to say on key press 1. Okay. I want my animation, send animation controller event, and I'm connecting. You see the color coding. So green can only connect to green. Red can only connect to red. Gray is your return function. Let it carry on. So my unit, send animation controller. Okay. And because I don't know what it is, I can go and browse. And I can choose. So I've set up animation end, LHS, and RHS. Now, anim end is an automatic one that comes at the end of an animation. And if you don't have that, your animation plays and it loops over and over. So you want, at the end, you want this event to signal that you have ended. So I'm going to choose LHS. Okay. And I'm going to say, on my key press, here, when keyboard 1 is pressed, play this for unit that. Okay. And when this is successfully finished, I want to play LHS pressed. Okay, makes sense. Very easy. Like, it actually feels like very, very easy. For anybody who's had to type in this code and has forgotten how to code, looks at this and goes, oh, well, I definitely want to play with that when I get home. So we have this. So when if I look and I go on keyboard button and I press 1, I'm running this event, and after this event is finished, I'm getting a print to screen functionality. So I go, click play. When it runs, push 1, and it causes that, it pulls that action back. Okay. If I want to go and I want to quickly animate the second level of that, I can just duplicate this. So I can take out the code that I want. So choose there. Paste it down. And just change it. So when I press 2, okay, this unit, the same unit, plays my RHS action. So if I push 1, it runs and resets. If I push 2, it goes and resets. So what you've seen there is how we created a graphic or a CAD model, how we've taken it into 3ds Max and animated, given it a little bit of motion, how we've taken it into a gaming engine, configured the controller, and from the controller we've set event triggers that can be called in the flow code that we're using. We have not written a single line of code, but we're able to do this. Now, I was told by a friend not to go further because he says I'm going to lose everybody after this portion. But you can start incorporating physics. So if I wanted to, on this action here, instantiate a block cube, I could. And I could have a block with physics applied fall down. If I wanted to create different interactions from this, I can link that up. I just go deeper into the flow script. So whatever I want to, yes.
How would you incorporate proximity? So yeah, I should be close to the button.
So what happens with proximity? Okay, let's look at the physics-based environment because somebody asked. Thank you. Okay, so the physics-based environment here is actually quite interesting because what happens is you've got three different kinds of physics objects. You've got the one that stays still, the one that moves, and the one that has to be moved. So keyframed, dynamic, and I think that one's static, something with an S. So that's the one I don't use because it can't explode. Yes. So what we do is before it has a physics actor on it, nothing can collide with it, nothing can move, nothing can interact with it. So you have to apply a physics-based actor to it. Okay. So you know in a video game when you can't walk through the wall, that's there. It's because it's got some kind of physical actor, a rigid body, something that will stop you from going through it. Now that is an extra level of graphics. Now what happens is on a collision-based detection, you have a model around it, a sphere, a cube, a whatever that's inside there that doesn't render here, is invisible here, but renders on a physics level. So when certain volumes interact with each other, it emits a trigger mechanism. And it's on collision, do this. On exit, do this. So have you ever played the old space shooter games? And have you ever wondered what happens when those the aeroplanes go beyond the screen and they disappear? So what happens is on a 3D based environment, you say that anything that exists out of a certain boundary, once it leaves, it must be destroyed out of memory. Otherwise, your application is going to like overrun and it's going to be destroyed. Well, your device will be destroyed. So we have that, and we can apply static, dynamic, or keyframe. Dynamic will allow us, once it's applied, and once we save it, and we close here, when we play this now, it's going to fall through the floor, and it's going to continuously fall, because we've applied a physics-based engine. Now, what's interesting about this is the physics engine that's being used is the NVIDIA physics-based engine. Oh no. Did it fall? Did anybody see it fall?
Mm-hmm.
Okay, so it's the NVIDIA physics-based engine. So it assumes that gravity is set up at 9.81 meters per second squared. So go again. Yeah. So it falls, it stops. So this is a physics-based. I tried to set it last night and I didn't want to do it, so I was like, I'll just give up. But it worked now. So when it hits that, it stops and it collides on that. So we can do that. So what we can do is we can instantiate, knowing a position. On calling this box, we can bring something into existence, and when we click that button, we can make it explode, or whatever we want to do with it. So we like to make things explode. I'm not going to make things explode, but yeah. So what we can do is we can say, I want to create an object. Okay, when this button is pushed, I want to go unit, create unit, unit spawn, something like that, spawn unit. Spawn unit on position. Okay. Choose the unit. I can even do a house if I want to. If a house is loaded, it will look at everything that's inside the area and it will put it into place. Right now I want champ box. Okay, and I want that at 100. So every single time I click the LHS button,
It's basically 3D Max with a bit of dynamo.
pretty much, right?
How do you figure out the vector, like its actual position?
It is the actual. So when you're working with that, it is the. Yeah, it it's very good if you're familiar with the Cartesian, actual coordinates that it is in 3ds Max or AutoCAD or Revit or anything. It's the exact coordinates.
Okay.
So it does kind of require you to model in proper units like millimeters or that.
Ah, gotcha.
That's it. So we got that. So we're spawning it at 100 units up. I don't know what this is, but I know it should work. And yeah, so we go up. We can play. Okay, and we look. We search. Oh, there it goes. But guess what? We can do, it says bouncing, it's getting there. Now we want to get like 10.
Dane, just a matter of question, if you had set all of this up in your 3ds Max environment,
Yes, you can as well.
how,
If you
how
wanted to
easy
set a
is it
level up.
then to simulate it in Stingray? Like pull it into the game,
Okay.
because most of it is done in 3ds Max.
Yes.
Experience.
So the way that it works is there's a thing called the DCC link in 3ds Max. It's changed because 2018's got Max Interactive and stuff now. But theoretically, and I've tried to get this to work, but the way that it's described in documentation, which doesn't work yet, but I'm sure there's a way, is you're supposed to be able to go to each unique asset that's inside there and sync it back. So if you have a character that's in a scene that you want to work with, you should be able to select it, make your adjustments to it, and select it to swap it backwards and forwards. Now the reason you're supposed to be able to do this is if you're building something like in Revit and you want to make a door interactive, you want to be able to animate it, and then once the door is interactive, you don't want to have to replace the entire Revit model in order to do that. You just want to be able to sync the door and the one occurrence of the door that can be copied to all the other doors that's inside there. It doesn't work seamlessly. You know, you have to tweak it and work with it and understand where your transforms are because they're all weird. But that is the promise. Now, this is still, Stingray is still very much in like a beta test. You know, you won't find somebody actively trying to sell it to you because there are multiple versions coming out. I'm using 1.8 at the moment, which came out a couple of months ago. But you'll battle to find, on 1.8 you'll battle to find tutorials or even sample files that you can use. You literally have to create your own. Now, but what is nice with it is, okay, and they've also removed scale form. That's why I didn't go into it, but I'm going to bring it up. The scale form is the dashboard 2D based environment for designing a dashboard, for designing a heads-up display, menu items and that. But they found it too complicated. And they're like, no, let's do something else. I don't know what else they're doing yet. But what I wanted to show you today is just basically this. You know, working up and just kind of the basic game as per se. And when we're done with this game, and we want to sell it and we want to make millions because now, you know, everybody wants to play this, you push one and blocks fall from the sky. The next Minecraft. No, what you have is you have a very unique, it's unique to other things, but it's not unique to the gaming industry, in the fact that you can deploy to multiple devices. So when you deploy, okay, and which means to create the package or whatever that you want to do, you can deploy to Windows, you can deploy to Android, you can deploy to iOS, PS4, HTML5, Xbox, and a wide variety of other things. So which means once it's ready, you can take that which you create and publish it for tests on your devices. This is a multi-device publishing interface. So before, if you wanted to create, or before, like if you're not using gaming development software, and you want to create something for an Android phone, you have to go into the Android development kit, Java, working inside there. If you're working on iOS, you have to go open up your Swift development tools or whatever you're using, and it's very difficult to port it from there. But on a gaming-based interface, even if it's not a game, it gives you a deployment option to test it out on a multitude of devices, which I think is pretty neat. Okay, and then when we finish with that, we package it up, we can give it names and that, and this is actually ready for development testing or release. Now it's not proper release, it's not there, there's a lot more that goes into it. So there are other tools inside it, but they're coming and going very, very quickly. So on the sound level, Autodesk uses is partnered with WWise. So you'll find WWise. If anybody who works with sound might know it. But we work with that. Scaleform as well also works with Unity, it works with a lot of other things, and it's also used in the electronics industry to create dashboards and mobile screen interfaces and that as well. You've got a very intelligent navigation system, you've got Beast Renderer, which has been phased out. So they've taken a lot of stuff out in order to simplify it, but they haven't really said what they're putting back in its place. But I still think that the way that it's working and the way that it's going is it's an interesting side tool to look at. And for anybody who wants to go into gaming without having to learn how to code, and just to create little basic applications and simple things, like I would recommend it. It's a lot of fun. Now, my computer is terrible. I don't have a really good graphics card. But when you start looking at the graphics that Stingray can produce, it is a lot better than some of the other platforms that you can see. So the graphics engine behind there, like your fluff and your water and everything, I wish I could show you right now, but they updated it and didn't update the Museum of Learning. The water, the textures that you see are phenomenal.
Does it have its own engine?
Yes, Beast.
Ah.
So it's better than Unity?
It is, well, look, the new Unities are good.
Yeah.
But it's because it syncs with 3ds Max and it works with that, it's got a better feel to it. It's the water. Okay, so the way that water works in here is when you're animating water, it allows you to take two textures over each other, two bump maps, and you can actually move them and control the speed at which it moves. So you can have water that actually reflects and does what it needs to do. When it comes to your like, lost the word now. There's a word that when you have like a wax type material that you can see the light shining through.
Subsurface scattering.
Subsurface scattering, yes. Your subsurface scattering is a little bit more, it's real-time based. So it's nice to see subsurface scattering without having to render it and see what that works like. Yes.
Oh, does it have floating physics?
Does it have?
Floating physics.
No.
Like
No.
for, okay. For
It
water.
might, I don't know.
Oh, okay.
But it has really good reflection probes as well. So that's one thing as well. Here is weak, and my computer doesn't run reflection probes. I've been asking for a new, stronger PC for the sole purpose of reflection probes. But the reflection probes, if you go to YouTube and you start seeing how the quality of the things you get back, reflection probes are really unparalleled. The amount of reflection details that you see inside it, and it's great.
So
Yes.
just a quick one from the architectural side of things. So, in an architectural practice, we're more invested in, the output. So we are invested in visual fidelity, interactive tools, and you just outlined that they're giving and taking away many tools.
Yes.
So if we get excited by Beast and we actually love the visual fidelity that we're getting out of the model, that's taken away, that's a lot of research time lost in practice. And if we're talking about the graphic user interface and all these displays that Scaleform is meant to put together, if we invest in R&D for Scaleform developers, and that's pulled away, we're going to end up quite reluctant to invest in Lua or whichever other third-party elements are part of this Stingray offer. So it's almost explicitly saying this is a tool to just manipulate, transform, as well as play around with this offering up until a later date when there's a game.
No, you're very right. Okay, and I know from the conversation that you've just said that somebody somewhere spent a lot of time learning Lua to try and understand
So I'd hate to
it,
get
and
into
finally
that
figured out
and
how it
taken
works, and then going, damn it, now they're taking it away. I know, I feel the
So
same.
I mean,
I have
with
the same
competition like Unreal, everything is inside. So when I learn one tool,
Yes.
I know that in the next iteration it's improved, not taken away.
Yeah. Okay. So yeah, I don't know what they're doing with that. I have no idea. I would love to know, because I know I spent a lot of time trying to get my handle around Scaleform. It is semi-complicated, but once you click, you're like, wow, this is easy. But there's a lot of things that you have to do before you do the thing that you have to do.
Yeah.
It's weird. So do any of you know Lua? Okay. Well, so the Scaleform-based Lua, you need to get the variable or the component that you need to use. Then you need to get the next component of the next level of that, and then you use that in the two pieces of code in order to get the output that you need. So it's weird. Like, you have to think in like 3-dimension. Like it's crazy. It's fun, but It makes you do good presentation. Okay, yes. That is, yeah.
How would you create that use the same button to press either of the sides, but when you're close to one, close to the other?
How would you use the same button to press that? Okay, so you would have a collision volume around the character that you're using. It's the same as if you wanted to activate an elevator switch. So you would go into whatever is in the vicinity or closer to the central point.
Let's say, because for example, in a game you would use one interaction button. You would not use a specific interaction button for every single interaction in the game. You would use, for example, X.
Yes. Yeah. So one button to activate it on different times. So alternative or during collision or proximity?
Like just for example, if you are pointing at this button and you click X, this will activate it. If you're pointing at a different button, then
okay, yes. Ray tracing, raycasting. Okay. Do you guys know what a raycast is? Okay. So yeah, that's a bit more complicated. So what happens is when you have a computer, you have a camera that's pointing, and that's got a one more minute. Okay, yes, one more minute. Okay, so what happens is you have a camera that's pointing. What you want to do is you want to create a physics-based raycast, which is a single line that goes through everything. That single line, because it's a physics-based element, needs to pick up another physics-based element. So when it collides with another one, it'll give you feedback on what is the first thing that physics thing is touching. If that is that, you use the output of that to control whatever you use. Thank you, guys.